In this video, we will go over the product and the quotient rule. The product rule is the following. If we want to compute the derivative of f times g, then we can compute it by doing the derivative of f times g plus f times the derivative of g. This is sometimes called Leibniz rule, and the intuition is as follows. If we have a rectangle of length f and g, and we make an infinitesimal change in the area, so f changes a little bit by delta f, and g changes a little bit by delta g, then the total amount that the area changes is delta f times g plus f times delta g plus something kind of small, delta f times delta g. So the small change of this area f times g is roughly delta f times g plus f times delta g. Now this is just intuition behind the product rule, so now let's prove the product rule. By the definition of the derivative, it's the limit as h goes to 0 of this difference quotient. Now we introduce two terms. We add and subtract the term f of x times g of x plus h. Then we can group together in terms of g of x plus h and f of x so that we get something like this. But notice that the terms in front of g of x plus h is the difference quotient, and likewise here we have the difference quotient for g. So when we take the limit as h goes to 0, this will go to f prime, and this will go to g prime. This will just go to g of x. And this proves the product rule. Let's do a quick example to take the derivative of x squared times sine of x. This is a product, and so we'll take the derivative of the first times the second plus the first times the derivative of the second function. And so we get something like this. Next, we introduce the quotient rule. So given a quotient of functions, f divided by g, the derivative is given by this formula. We have to make sure that the sign here is minus and that we divide by g of x squared. This will be proved in a future video, but for now let's do a quick example. If we want to take the derivative of this rational function, we plug into the quotient rule so that the derivative of x squared plus x plus 2 is 2x plus 1 times x cubed plus 1 minus the numerator x squared plus x plus 2 times the derivative, which is just 3x squared, divided by the denominator squared. And so this will be our derivative. Let's do one more example. If we want to take the derivative of the tangent function, tangent is by definition sine divided by cosine. Applying the quotient rule, we have cosine squared plus sine squared divided by cosine squared. Note that we have a plus because the derivative of cosine is minus sine, and then times sine gives you minus minus sine squared, so plus sine squared. Cosine squared plus sine squared is 1, and 1 over cosine squared, or rather 1 over cosine, is secant, so this is secant squared. So the derivative of tangent is secant squared.